Assessing the capabilities of large language models, LLMs, is often challenging, in part because it is hard to find tasks to which they have not been exposed during training. We take one step to address this challenge by turning to a new task, focusing on symbolic graphics programs, which are a popular representation for graphics content that procedurally generates visual data. LLMs have shown exciting promise towards program synthesis. But do they understand symbolic graphics programs? Unlike conventional programs, symbolic graphics programs can be translated to graphics content. Here, we characterize an LLM's understanding of symbolic programs in terms of their ability to answer questions related to the graphics content. This task is challenging, as the questions are difficult to answer from the symbolic programs alone. Yet, they would be easy to answer from the corresponding graphics content, as we verify through a human experiment. To understand symbolic programs, LLMs may need to possess the ability to imagine how the corresponding graphics content would look without directly accessing the rendered visual content. We use this task to evaluate LLMs by creating a large benchmark for the semantic understanding of symbolic graphics programs. This benchmark is built via program graphics correspondence, hence requiring minimal human efforts. We evaluate current LLMs on our benchmark to elucidate a preliminary assessment of their ability to reason about visual scenes from programs. We find that this task distinguishes existing LLMs, and models considered good at reasoning perform better. Lastly, we introduce symbolic instruction tuning, SE, to improve this ability. Specifically, we query GPT-4o with questions and images generated by symbolic programs. Such data are then used to fine-tune an LLM. We also find that SITE data can improve the general instruction following ability of LLMs.